Hi, I'm Jelle, and I'm currently looking at a Blazor default app which is running on my local host, and I, as a developer, am pretending that I just got this code and it needs to be tested. So first let's take a small look at what the code does. So it has a home page. We have the well-known counter page where we can click and increase a counter. And we have a fetch data page which will get some data from memory, which we're not going to look into. Our focus as a tester today will be the counter page. So let's take a look at the code. We have a test class. It's called the counter page tests, and it's using Playwright for the framework. So it's UI tests. So you can see when I run these tests, it will actually start up a browser and it will perform the tests for me. So I've actually added some waits because otherwise it would be too quick, and I've made sure that it runs with head, with non-headless. It runs an actual browser instead of fading a browser to the back. Just, you know, it's more interesting to look at. And as you can see, these tests, they succeed. So apparently I'm done. The counter page works, and the tests that were written by someone else, they're perfect. I don't have to do anything. So this is actually something I hear a lot when people look at tests. Is yeah, code quality, code smells with tests. It's just test code, whatever. And I think that that's probably the I'm gonna be I'll try to be nice. It's stupid. It's really dumb, because what is the stuff that you're maintaining the most in your application, especially once it's up and running and you're adding new features and stuff, is your tests. You're going to spend a lot of time in your test code. So some teams, they have dedicated automated testers. Some teams delegate this task to to team members, and everyone should be a tester. And I think in both and in other cases, it's really, really important that you not just maintain your actual production code, but you take a look at your testing code and you determine whether it's actually the best code it can be. It's really, really hard to go back to test code and refactor it if you don't know anymore what it's doing. And there's a lot of potential problems that are also, of course, code smells in typical code that can also pop up in test code. And we tend to decrease those smells in priority because it's just test code. And I'm going to show you how easy it is to make sure that your test code looks a bit better, functions a bit more well, and is a lot more maintainable. Alright, so we have a test. Actually, we have two tests. So the first test, what it does is it checks, well, it visits, it launches a browser. Make sure the browser has a context. It visited the specific counter page. I've added a timeout because a timeout feels better than we can actually see the page. And then it will look for a button, and it will make sure that it has the click me text, which is the button that we saw earlier that will increase the counter. Then it says, all right, we're gonna click twice, and then in a little for loop it clicks the button and then waits, because the button might take some time and we're not sure whether the button has been clicked. So let's wait a bit, let's have a little timeout, and then we're going to look for the current count, and we're going to say, okay, on the page it's going to be a current count text, and it's going to have a number, and we want to make sure that the number of times we clicked and the number displayed here are actually the same, which makes sense. Which is what the test also does according to its title. Given that the counter starts at 0, if we click this counter button twice, then the counter text should be 2. Perfect title. Now, after that we make sure that it's actually the same, and then we close the context and we close the browser, so we clean up after ourselves. The second test we have is kind of similar, but it actually does something that is a different different test case. After launching the browser and the page and clicking it once, we'll reload the page, and then we'll see whether after reloading the counter has been reset back to 0. Now, of course, is this the intended functionality? Apparently so. It's of course a bit of a weird use case in this specific demo, but that's actually why it's so important to write good tests, because when we see now the test title, given counter of 1 when reload, then counter 0, you'll know immediately what apparently was intended for this code to do, because the tests actually spell it out for you. So I'm actually kind of happy with the test names here, although there's a lot of other different ways of writing test names that may fit your needs better. So that's not what I'm going to focus on, but I'm going to focus on some code smells in this test class. So I'm going to show you the test project here, which is where the test class resides. And currently this is all the test code. So apparently the previous automated tester left the project after writing these two beautiful tests, and it's up to us to make sure that these tests are maintained. So I'm sure that many of you have already seen some things that they disagree with. Good. Let's make sure that we fix all of them. So the first thing I think is already kind of obvious is that we have a very long class here. This test class, it only has 2 tests, and still it's already 60 lines long. That feels a bit out of what we intend for classes to be. So we want to make sure that a class has a single responsibility, and that's also true for a test class. So what should a test class do? A test class should arrange, act, assert, and the arrangements should be as quick as possible and as low. The number of lines should be very low. That's the best way to say that. It's also really difficult to maintain a long class, because I'll scroll and I'll look for what exactly happens where, and I don't know whether some code is necessary or not. It's really hard to see, because all the code's just there. There's no naming, there's no thoughts, there's just lines of code one after the other. If this code ever changes and I need to change the test, I'm in trouble. So what the first thing that I would do is I would focus on the single responsibility principle here, and I would go, all right, so this class actually is doing at least 2 things. It's doing setup, it's doing kind of test infrastructure, and then it's doing a lot of actual arranging, acting, asserting stuff. So it clicks the button, and then it checks where the text has increased. So that's not how we want to do it. That's the first thing. So we would separate the infrastructure from the actual testing code. So basically, I would actually go as far as just have separate folders for infrastructure code. Even in your test project, you have infrastructure code, and then you have actual test classes. Or in the case of a playwright, I would expect page test classes. Second, what we're looking at, even if we have a long class, we also have very long methods, which is the kind of same single responsibility problem. So if we have a very long method, and if we would start separating out the infrastructure here, we would still have very long methods even in the infrastructure. And we want to make sure that code, that methods are quick, that they do one thing, and that you know what you put in and what you expect out. And in a test class, of course, it's a bit different. You have maybe no input, or you create your input. But we have setup and teardown classes for that, for instance. We want to make sure that every single method has a single responsibility. So a test attribute above a method does not excuse a method from being very long. Each method has a purpose. And that also really increases reliability. So for instance, if I would have an infrastructure class that's called let's call it counter page, not counter page tests, but counter page, that has the infrastructure for all tests that work on the counter page. that would have small methods like click button, and the counter page infrastructure will handle all the locators and how clicking is done in this framework. But as a user, you'll have a click button method, maybe a counter for how many times you want to click it, and it will handle that for you. You can also maybe have a retrieve counter text method or some sort, where if you want to assert that the counter text is correct, you'll get that code. You'll get that code from the counter page infrastructure class, and you don't have to think about exactly how it does it. The test just gets it, and then it has the text to work with, and you can you can assert whether the text is correct. Another thing that I think many of you will have noticed is that we have a lot of duplicate code. We have 2 tests. If we would have 5 tests, we would have even more duplicate code. We set up a browser each time. We go to the same page each time. We have a lot of waiting that we repeat. We locate certain stuff using the same logic. We close the browser, we close the context. That's repeated not in this test and each test that we have after. Again, this duplicate code, if we, for instance, remember, oh right, the timeout needs to be different, or the button with the click me text has changed and it no longer says click me, but it says something like click here, and we change that in one test, and we'll have to change it into the other test as well, which is error prone. It's the same for production code. We want to make sure that that kind of text is in a single place, and we want to make sure that if we change one thing in the production code, there's only one place in the test code that we have to change it to. So yes, that's still a kind of duplication, but that's test duplication, and we do that by design. Alright, so that's a few of the problems that we've seen in this code that will also apply to actual production code. So if you're a developer, this is the kind of stuff that you would see easily, because you're like, oh, on production code I would do this differently. So in your test code, if you care enough, you might do that differently too. But something that a tester might see is that some of the locators that we're using here, well, I alluded to it earlier, are kind of fragile. The button has text string click me. That might change a lot, and that might change often. That's a fragile locator. We want to make sure that we use those locators that are going to be consistent and maintained, and will change the least amount of times possible. Of course, user interfaces change, but let's take a selector that doesn't change as often. For instance, if we're looking at the text here, the current count, and we inspect it, we learn that it actually has a role tag. The role is status. That's not going to change, because that's actually the description of this paragraph. We can't just target any paragraph, because there's going to be multiple paragraphs on this page, but there's probably going to be only one that contains a status. And then we don't count whether it contains the text current count, or it contains a certain kind of style or a certain kind of class. The role is actually what we can use here to figure out which paragraph we need to be checking. Alright. Another one that's not specific, well, that doesn't often occur in production code, I hope, is uncertain weights. So I've cheated a bit, because Playwright actually does a lot of this by default, and I've added some weights just for the demo purpose. But we'll all agree that in test code we see this kind of stuff all the time, where we say, alright, test, click this button, or go over here. Now wait a bit, because we're not sure whether the page has loaded yet, so we need to twiddle our thumbs. And now, yeah, that probably, at least on my home machine, it works. Probably the page has loaded, and we can start finding elements on the page, and we can start asserting. We have a wait here of 2 seconds. Let's hope your code doesn't do that, but waits for like 50 milliseconds, those are very common. And those are weird. Why would you just gamble like, oh, maybe it's 50 milliseconds? Your page gets slower, suddenly you have to wait longer. Or worse, your page is actually much faster and your test runs for additional time. Each time you run your test, you have to wait needlessly. And your test runs are going to be slow and everyone's going to complain and people are going to move the tests out of the build and suddenly your tests are all gone and catastrophe happens. Okay, maybe it's not that bad, but let's make sure that the waits that we do aren't uncertain. We don't want to wait for, I guess, a second. We want to wait until the button has appeared. Now, stuff like that, as I said, Playwright does this almost perfectly by default, but there's a lot of UI frameworks where you could just add a wait until or a wait for construction, which would work a lot better than waiting for a timeout. So that's another one. So let's wait intelligently. I think it's really important that in your test code we make sure that we only have one assert. Basically, what you could do is make sure that the page here has a we're going to get the button. We could add an expect here to make sure that the button has a certain class or is has a certain kind of style or text within the text. I see this a lot, UI tests where we start just testing whether everything is in place. Well, first, any change to your UI will make sure that you have to rewrite your test, but that's not the biggest problem. It's not clear what your test is actually doing. It's not clear whether your test is looking at the class of the button or it's looking what the clicks do or whether it's making sure that the text is correct. We just want to have one assert in a test. Even if that feels like a test may fail for an undefined reason, well, then your test should fail with an error. Then your test should throw an exception. Basically, all your infrastructure code in your test should not be running assertion, basic test assertion code. It should actually throw errors because the infrastructure is the basis on which you build your test. And if that's not working, then the test didn't fail. The test was actually useless. Or well, not useless, but did not assert or deny whether your functionality was working. The problem is even deeper down. So if we have multiple points of failure, where a test has multiple asserts, we should get rid of that too. So luckily, that's not the case in this code, but you could very easily think of a scenario where we have code like this, basically, where we expect the button to have text. Well, we've looked it up with text, but this kind of code, to have attribute, to have a class, maybe that's in the middle of your test, and that's weird. You shouldn't do that. So what would it look like? Because I'm not a fool, I haven't been changing this code live. I can't. I don't think that would have worked well, and it would have been a lot of typing and a lot of changing. But what if that would actually had happened and I changed all the text? Well, first, as I said, we would have an infrastructure. I'll put it actually in the infrastructure folder. Yes, we'll adjust the namespace, and we now have a code smells.test.infrastructure, and I think we should use that here as well. And now in the shared, so I would have this in the page tests. We have a beautiful new test class, which let's actually call it what it is, counter page tests. Alright, so we have a counter page object in the infrastructure, and that's going to do some of the stuff that I said was necessary. So first, it will take the Playwright page object in its constructor. It will know text that's going to be reused. It's going to use that as a property. It might be necessary to make sure that property is actually public if we're going to use it to look for text, but I've written it a different way, which can also work. It handles all the finding buttons logic. It handles all the clicking logic. We have a method that says click. The test doesn't care how clicking works. It just wants the page to be clicked, or the button to be clicked in our case. And it has a method which is separate from the clicking the button, even though we could have combined it, but it's separate, that will check whether, given a number of clicks, the text that appears on screen is what we expect. This is basically infrastructure. We don't care, we're not going to assert anything here. This is how we currently define the counter page to work. We could say this is the production code of the test code, but let's call it infrastructure because that's a lot less confusing. And here we have the reworked counter page test, where you can see that first, well, it's just 10 lines shorter, but it has a lot more methods. And the tests themselves are a lot more readable. So first, let's look at the setup. Basically, whenever we run a counter page test, we want to run the browser, and we want to make sure that it goes to the counter page. So we're not going to repeat that. That's just in the setup. That's just an assumption of our counter page tests. And when we end a test, we call the teardown, and we make sure that we clean up nicely. So that's not in the tests themselves anymore. And I think you'll agree that even looking at the tests, they are a lot more intuitive in what they're doing. We're calling the infrastructure here. We're saying, all right, we have a page. Let's put it into the counter page, and let's interact with that infrastructure instead of with the actual Playwright infrastructure. And we have a number of clicks. Let's click the counter button, that number of clicks, and we check whether the status equals what we expect. I'm returning a boolean here. You could also return a string and then check whether the string matches. That's also a possibility. That's more of a, I would say that's more of a tester's preference that's in play here, but you might disagree and say this is bad code, in which case, well, the code is linked there and down there, so change it up, download it and make it even better. I'll be very happy to see what you've made of it. And the other test is basically very, very similar, because what we're doing was very similar, but we needed 20 lines to do that very similar thing last time, and this time we do it in less than 10. So there is a bit of duplication here, and I say that's a good thing, because we want the test to be readable in isolation. So we want to say, okay, we have a page, I think we should duplicate that. Yes, we define a number of clicks, yes, we click the counter button, but it also makes it really clear what we're doing differently, because, alright, apparently this test does a reload, that wasn't in the other one, so that's good. Alright, so we are asserting in the same way, and you could say, well, let's make that a private method. Let's make the assertion of the number of clicks in the expected text to just be a repeatable construction. But then your assertion would not be in the test itself, and your test would become less readable. So, in my opinion, and my opinion is actually fact, that's a bad idea. I would make sure that if you're just reading just the test, you can exactly see what's happening, and there's no like assert number clicks method here, and then that's just the end of the test. I think that's very, very unreadable, and it's prone to making really weird private methods as well, where you have like 5 arguments that you pass in, and they're not all used in every test, and it's just going to get messy. Yeah, so we have a refactored, less smelly piece of testing code here, which is my way to show, I think, not only writing test code, but actually refactoring test code is really, really, really important if you want to have a maintainable code base for your app. And it's getting easier and easier to do, because testing code and UI testing code and production code are getting more and more similar in design, architecture, and the coding language, because they're both C# here. They're even very close to each other in the repository. Yeah, I think that's all I wanted to say today. I'll be really interested if you have more ideas on refactoring code, so I'd love to hear that. and of course whether you make any improvements on my code still. Thanks so much, and I'll speak to you soon. Bye bye.